right? All right, so next slide. What about the technical stuff? We have some other things, authentication and authorization, that need to be handled in our systems. And right now, we haven't really allocated any responsibility for that. So there is another service. I call it ITOps. Hint, you've seen the ITOps thing before in one of those previous slides, where its responsibility is keeping information flowing and secure in the enterprise. So just like all other services, it often has the sort of cross-enterprise component to it, where it will have components running in every system. A lot of the technological, technocratic responsibilities of our systems fall under ITOps. So first of all, you have physical things like which web servers am I deploying to? What is the connection string to the database? What's the error queue that things are going to be going through? So all of the more physical configuration things are the responsibility of ITOps. Other things, authentication, so the user login screen, sign in, sign out, that kind of stuff. Also the responsibility of ITOps. Therefore, things like users' permissions and impersonation that we talked about earlier, also ITOps responsibility. So its focus is a lot of the times the technological glue between all of the other services and systems. Some other things that often come out of this, things like, well, which ORM are we going to be using? Are we going to be using Entity Framework? Are we going to be using in Hibernate? That's an ITOps decision where we'd want to have all of the services standardize on a given type of ORM that we're using. If we're going to be using a message queuing technology, which one is that? If we're going to be using a service bus technology, which one is that? So a lot of infrastructure decisions, logging, which container are we going to be using, ninject or structure map, or all of those choices. All of those are ITOps type concerns. And as much as possible, we try to design our system in such a way that the services don't need to take a direct dependency on those pieces. So the cross-cutting concerns of saying, okay, logging is going to be happening without people having to write log this and log that. And same thing with containers to say, okay, don't do a service locator pattern. Instead, just declare dependencies in your constructor, and the container will magically wire all of that up for you. So we try to choose design choices and infrastructure choices in an ITOps to say, as long as everybody follows these conventions, then when everything gets hosted together, magic will happen. All of the transactions will head to the database the right way. All of the logs will go to the right place without people having to take dependencies on the actual infrastructure. So those are other things that fall under the purvey of ITOps, all right? I want to say a few words about authorization because that's a little bit of a tricky thing. When talking about authorization, it's often very much dependent on what is a user allowed to do. Be careful that you're not moving into business rules territory. So for example, given that a user is authenticated, are they allowed to access system A or system B? That basic level of authentication is ITOps. The basic level of can they access system A or system B is ITOps. If we get into something like, is the user allowed to transfer money out of this account? That's a business rule. Say, are they the account owner of this thing or not? That's not ITOps. Right? So ITOps, in terms of authorization, is really stopping very early to say, okay, I know this user, they can access system A, they're not allowed to access system B. That's just about as far as we go. All right, so be careful of any sort of centralized identity management solution that includes all sorts of business logic information about who can perform which action on which entity and all sorts of roles like account owner. Once you start moving from generic things to be entity specific, you've gone too far. All right? Pete?
So I'm fine with the different services, sales and billing and stuff, and then the branding service, which doesn't talk to them all, but gets data from them all. But
right.
How is IT operations a service? How is a connection string
Mm-hmm.
part of a service when they all can't do anything without it?
So, in essence, ITOps is the physical glue service that we talked about before, the green Lego board onto which everything else plugs in. So, remember when we said services are primarily logical? Saying, as long as somebody gives me a connection, then, and as long as my tables are behind that connection, I'm good. But how that gets configured, I don't really care. Just give me a connection object and make sure my tables are in there. So that's the services focusing on being the logical view and the development view more so than the deployment view. All right? So you can say, well, the services don't, how can they be autonomous if they don't own the deployment? Well, it's not the physical autonomy that we're looking at. Okay? It's the logical autonomy, it's the maintainability, it's all of those other concerns. To say, yes, ultimately, for a given system to work, we'd need ITOps, we need branding, we need all of the services in the middle to work together to make a thing happen. But most importantly, that we can do that without them having to talk to each other very much. And we can use all sorts of interesting event-driven composition interception patterns to make sure all the logging happens and everything ends up talking to the right database and all of the error messages end up going to the same error queue. And we can do that without any service really being aware. They say, well, I threw an exception. Where does that go? None of my business. We have some really smart ITOps infrastructure. They're going to solve that for me. All right? So it's those different views of architecture that say the business-oriented services, not concerned about the deployment view. All right?
Yeah. The ITOps service in the...
Is there ITOps service in the sample code? That's a good question. I don't remember off the top of my head. My guess is probably not very much. The focus is much more on this sort of view model type of composition. But again, I'd say that for the most part, when it comes to logging and containers and ORMs and things like that, already most developers have been applying good practices around how that gets injected and handled across their code bases. So it's just saying the stuff that you've already been doing, we have a name for a service that owns that. Keep doing what you've been doing. Okay? So some other details, it's rare. It's really rare that ITOps is going to be subscribing to business events and definitely not really publishing events because it's more of that physical glue service. One rare case that if you run into it, then okay, you can say that that's fine. If you need to have an HR service for a bunch of other reasons, and that HR service is publishing events like employee hired or employee fired, then that could be a reason why ITOps might subscribe to that and say, oh, when we hire an employee, we should give them access to all sorts of systems. So that can be sort of an automated provisioning thing that happens in ITOps. So that's the case that I've seen that kind of break the exception to the rule that ITOps doesn't really ever subscribe to anything. But don't go just creating an HR service so that you can say ITOps also subscribes. All right? One other thing that falls under ITOps responsibility that is very different from all of the things that we've talked about so far is when we're dealing with integration. What we've talked about so far has been very much focused on the bus architectural style. But occasionally, we need to have our systems, our code, talk to some third-party system that is built totally differently and we have no control of. So when we need to do integration, that falls under the responsibility of keeping information flowing and secure across the enterprise. Now, occasionally what we'll need to do is export data to another system or import data that's coming in from another system. So if you look at this and you squint a little bit, you might say, that kind of looks like a hub and spoke pattern, right? That is the place where we do integration. ITOps implements that hub and spoke broker architectural style of saying, I need to pull data from multiple other services do some sort of really crazy XML transformation thing on that, and spit that out to that other system over FTP. That's an ITOps type concern. And similarly, the inverse of that. I get an FTP file dump from another system in some sort of crazy EDI XML format. I need to pull that out and reverse engineer that and pass that back to my services. So that's really what ITOps does, is if we need to talk to both incoming and outgoing some third-party system, it's responsible for dealing with those transformations. Keep in mind, we want to keep it as technocratic as possible. So try not to steal things that really belong in each of those services. Now, there's a pattern here that I want to talk about of how that type of hub and spoke model can happen, but not in a remote type of request response fashion. So you'll notice here that there's these interfaces called I provide something. These are interfaces like you'd think an in-process, in-memory interface that ITOps component is taking a dependency on, and that each of the relevant services provides some class which implements that interface. I'm going to switch to code in just a second so that you get an idea of how something like this can be built. All right? The important thing that I want you to take away from this, when we're doing a hub and spoke integration type of model, that all of the request response that's happening between ITOps code and business service specific code is in process. Two objects in the same process talking to each other. All right? It's not over the wire. It's not via messaging. It's happening in process. I'm saying, how on earth could you do something like that? Well, I'm glad you asked. So, all right. Going into Visual Studio. And let's go and take a look at billing, because this is the part where we said, all right, we need to actually go and do the billing. All right? So just to introduce ITOps here a little bit, I'll create a namespace for ITOps, where ITOps is going to have, let's call it public interface, I bill customer for orders, all right? And this interface has an API called void bill GUID order ID. All right? Now, inside billing, when we're saying, okay, we need to actually bill, this is the part, let's go back to the diagram that we saw over here in our architectural styles, buses, and brokers. This bit over here that says, okay, I got, give it a second, a service layer call that is talking to that BizTalk adapter thing. So that can be done in process, all right? So billing is taking a reference to the ITOps BizTalk adapter thing, the thing that actually is going to talk to the billing, all right? So that's what we're doing here. ITOps is exposing an interface called I bill customer for orders. Wait, let's switch that. There we go. And then the billing service takes a dependency on that, and you'll forgive me if I do this using just setter injection. What did I call that interface? I bill customer for orders. And this will be my biller. Okay? So in here, when it's doing the billing, in essence, it's saying, okay, biller.bill that order ID. All right? So this is how the billing code is talking to ITOps code. I want you to notice this because this is a very common approach where service code talks in process to ITOps code. Let me remind you of some other examples of this. The ORM that we're using, that is an ITOps piece of code. The logger that we're using is an ITOps piece of code. The service bus that we're using is an ITOps piece of code. Whether ITOps decided we're going to write our own service bus or use one off the shelf, whether we're going to write our own logger or we're going to use one off the shelf, most of the interaction between the business services and ITOps is in process, not remote. Why? What's the first rule of distributed objects? Don't distribute, right? So unless there's a really good reason to make these things remote calls, and there isn't, we don't. So what happens here in ITOps when we say, all right, now I actually want to bill the customer? This is where ITOps is now having its public class thing that actually bills. And let's call this via amdocs, and implements I bill customer for orders. All right? So we've done the first step of how billing ends up invoking this thing over here. All right? Now the next step, you say, well, we need to collect a bunch of data. We need the credit card information, we need the order total information in order for us to actually go and invoke the third-party payment gateway, authorized.net, PayPal, whatever, in order to charge the customer. So the way that we do that is we have, let's see, billing over here. What we'll do is we'll declare inside ITOps a bunch of interfaces that we've mentioned over here. I provide order total, I provide billing info. Now, a lot of times that will be done as a separate interfaces package, a separate NuGet package that we expose and saying, these are things that we need for the purposes of integration. So we might do something like this that says namespace itops.integration. And in here we'll have the public interface I provide order total. And this interface returns, let's say, the order total. And yes, you should not use a float for order totals. Yes, we know that, but I'm just going to do that here really quickly instead of using decimals and an actual money type. So get total based on the GUID order ID. Okay? And then we're going to have another interface called I provide, let's call it credit card, and we'll just return that as a string here, get CC details based on that same order ID. Okay? So ITOps exposes this NuGet package to the other services saying, this is stuff that I need. Okay? And then in its thing that actually bills, it declares a dependency on those interfaces. So again, I'm just going to do that very quickly via setter injection. Public, what did we call it? I provide order total. And we'll call this the order total provider. And we'll also take a dependency on the I provide credit card, and that will be our credit card provider. And that, when we get invoked and said, okay, actually go and bill this thing, then we'll say something in the form of var total equals order total provider dot get total based on the order ID that we have over here. Why did that end up being capitalized? We don't like that. And then we do var credit card equals credit card provider dot get CC details based on that same order ID. And then, now that we have collected all of the information that we need, over here we invoke third-party payment gateway. Okay. So notice what's happening here is that all of these interactions are in process, right? So it's this, remember where this process started. It was the order accepted handler inside billing that said, oh, okay, I'm going to take a reference on an I bill customers for order. That comes from ITOps. So in essence, the transaction from the messaging system is flowing through the biller object, which then flows through ITOps, which is asking, go get the total, go get the credit card details, right? So because we have all of this in-process interaction, yes, it ends up taking part in the exact same business transaction, okay? So the last bit of this is to say, well, how exactly did ITOps get an order total provider? Okay? How exactly did it get a credit card provider? So I'll do this really quickly with a credit card provider. The same pattern would exist for all of the other I provide interfaces. So we mentioned that billing, this service over here, owns the collection of the credit card information. So what we'll probably have is, going back to this picture, a billing component that is going to provide that information. Now, what would be the most elegant solution is that in essence we could create a billing.integration NuGet package. Say, here's an assembly, drop that in your runtime environment, everything will work. So how could we do something like that? We could create a separate package, and here I'm going to do it with a namespace, billing.integration, where in here, what we'll do is we'll have a class that implements, what did we call it? A credit card provider, which implements the I provide credit card interface, not surprisingly. Now, in here, in essence, what we're doing is we get invoked by ITOps to say, give me the credit card information. Now, it's very likely that we'll do a remote request response to some back end to go get our credit card information. All right? Remember, remote request response most often happens within a service boundary and not between service boundaries. So showing and collecting credit card information from the UI, that remote request response within a service boundary. All right? So here it's the, go talk to my back end and get the data. And ultimately return some sort of string. All right? The final piece of this puzzle is to say, well, how can we make it so that ITOps doesn't even need to know this class in order for, where was that? In order for this dependency injection to happen, all right? So remember how I told you before that we take our MVC controller registration and separate that out so that each service is registering its own controllers? We'll be doing the same thing here. Instead of creating a central bit of code that registers all of the implementations into the container, what we'll do is we'll say, billing.integration, this NuGet package, will register itself into the container. So one of the ways of doing that is that you hook into the onStart of your container. Now, depending on the container that you're using, that can be different in each case. If you're using in Service Bus, there's also this interface called I need initialization that you can plug into. So we can create a bootstrapper class for a given component that hooks into the in-Service Bus initialization pipeline. Say, when a process starts up, this thing is going to get called. And then in here, we already have a reference to the endpoint configuration. And then we can go via the configuration into registering components into the container. All right? So I can do a component registration thing to say register singleton, whether it has a component, things like that. Let's just assume that this implementation is going to be a singleton, just for argument's sake, and say register singleton, new, what did we call that thing? Credit card provider. All right? And I'm done. In effect, what happens is when the billing team takes this NuGet package and comes to ITOps and said, if you need credit card details, just drop this thing in. You drop that thing in, you're going to have an implementation registered for the thing that implements I provide credit card. So you just take a dependency and I provide credit card, take this NuGet package, and you're off to the races. You don't have to write any other code. Don't need to know what class implements it, how to get, that's my job. All right? And then we do the same thing with other pieces of code that register, that deal with the order total, that deal with any other type of information. All right? So I know it's a little bit involved, what I just showed you, but this is just regular dependency injection type coding that is a little bit more service-oriented friendly. Right? And it allows us to say, you know, this is my NuGet package, that's your NuGet package, that's your NuGet package. Let's take all of these three, throw them into the same process, and magic happens. All right?
Would you have a service URL somewhere here?
Would we have a service URL?
Or
What?
would it just be messages across the bus?
Okay. Oh, okay. Yeah. Now I got it. So what you're talking about is the bit in billing that says, go talk to my back end and get my data, right? So this part over here, again, when we think about how do we just normally make calls to a back end, often what we'll do is we'll new up some service proxy. Now I'm using the term service a little bit loosely here, but let's call it a REST service proxy. And ultimately, where is that URL that says, well, where exactly is that service that I'm talking to? That's coming from config. Who owns the config? ITOps. So this bit over here is just saying, new my back-end credit card service thing, credit card service thing dot go get my data. All right?
And the URL will be in the app config for the ITOps.
So it's the app config for that process. And because ITOps also has code running in that process, it's responsible for configuring that to say, well, where actually did I deploy that backend? Right? So the billing code that says, you know, go talk to my backend, just like with regular code today, non-service oriented code, we just do new my service and my service go get the data. All right? So the services logic is agnostic of what the actual URL is that it's talking to its backend for. All right? So this is just to illustrate that we can have integration happening. I hope that you're seeing here that we are doing a type of hub and spoke model where we have this broker thing that is saying, okay, you give me some data, you give me some data, goes and calls a third-party thing, gets a response back. All of the things that we mentioned before, but most importantly, we don't need to do any remote request response between ITOps and the other pieces of code, all right? Because the first rule of distributed objects is don't, okay? So use this type of DI stuff in order to get them all running together, and that gives you the nice automatic safety of a transaction flowing across all of these elements without you having to worry about that. And then the final bit of saying, okay, go get my data and that data, those types of remote calls, say, I might do that over a REST service, or I might go talk to a cache, or any number of other options in terms of where it gets its data from, all right? So this is where the broker architectural style ultimately connects into the rest of the bus environment.